Hi everyone, in this video I'm going to follow the previous video and talk about the concept of variance of x plus y. So basically we're talking about this version of x plus y where x and y are both random variables, right? So basically it's just saying that if we have a new random variable that's equals to x plus y, and the variance of this random variable. Okay, variance of x plus y. Let me just go ahead and write out the formula first. So variance of x plus y equals to variance of x plus variance of y and plus 2 covariance of x and y. Okay, we know how to do this part, we know how to do this part, and the covariance of x and y, two random variables, is new to us. So we'll focus on learning how to calculate this part here. There are two formulas to calculate this. So covariance of x and y equals to the expected value of x minus mu x times y minus mu y, and then you take the expectation of it, right? What it means is that each single possible outcomes of x, you're gonna subtract the mean, and then you're gonna times the y that's linked to this x, right? That means the two are happening together in a combination, and then you're going to take that y, the outcome of y that's linked to the outcome of x here, you're going to subtract the mean of y, and then you're going to multiply them together. Since it's the expectation, you're going to take the combination times their joint probability, you're going to add them up, okay? We'll see an example for this. And then another formula, covariance of x and y equals to the expected value of x times y minus the expected value of x times the expected value of y. Okay. Usually, for the purpose of calculation, this formula is easier to do, right? But sometimes, if the question already asks you to find this part, the expected value of x times y, then you should use this formula here, right? It depends on the type of question that you're given. Okay. Now I'm going to show you how to use this formula here, the one at the top. Let's go back to the example we talked about in last video. So I'm going to write it out. Okay. 2, 0, 2, 5, 10, 0, 0.1, 0, 0.1, 0.3, 0.2, 0.3, 0, and then this is for y and this is for x, right? Let me just write, right? 0.2, 0.5, 0.3, 0.7, 0.3, right? So again, the probability in each cell here in black, they are the joint probabilities. And the ones in red are the marginal probabilities for each possible outcomes here. Okay, good. Let's apply this formula here. So if we want to use this formula, the first value we need are the mu x and the mu y, or the expected value of x and the expected value of y. So we need these two first. So let's say mu x equals to expected value of x, right? What are the possible outcomes? -2, 0, and 2. What are their probabilities? 0.2, 0.5, 0.3. So we have -2 times 0.2 plus 0 times 0.5 plus 2 times 0.3, and this equals to this equals to 0.2 here. Okay, and then another one we need is mu y equals to expected value of y. So we have two values, 5 and 10. 5 is going to be matched with 0.7, and then 3 is going to be matched with 0.3 here. And this equals to 6.5. Okay, good. Next, we're going to apply this formula here. So covariance of x and y equals to the expected value of x minus mu x times y minus mu y. Okay, and we're going to look at each single possible combinations. There are 6 of them. So -2, 5, -2, 10, 0, 5, 0, 10, 2, 10, and 2, 5, right? Okay. So this equals to the first possible combination is -2 minus the mu 0.2 times. To match this -2, we have to use 5, to get this cell here. Equals to 5 minus 6.5 and then times 0.1, the joint probability. And then the next one is -2 minus 0.2. We're getting this one here. 10 minus 6.5 times 0.1, and it'll just keep going, right? Next set, 0 minus 0.2 times 5 minus 6.5 times 0.3, 0 minus 0.2, 10 minus 6.5 times 0.2 plus 2 minus 0.2, 5 minus 6.5 times 0.3 plus the last one, 2 minus 0.2, 10 minus 6.5, right? Times 0. So we have 6 possible combinations, and then each one out to the x minus the mean, y minus its mean, and then multiply them together and multiply the joint probability that they happen at the same time. So finally, with minus 1.3. This is the covariance of x and y. Good. Next, we need to calculate for our variance of x and variance of y. I'll do it here. I just still keep the table. I want to. Okay. So variance of x equals to the first possible outcome, minus 2 minus the mean, 0.2 squared times 0.2, plus 0 minus 0.2 squared times 0.5, plus 2 minus 0.2 squared times 0.3, that's equals to 1.96, right? That's the variance of x. Next, variance of y. Okay, variance of y is the same method. You have first value minus the mean square times the probability, the marginal probability, plus second value 10 minus 6.5 squared times 0.3, and this equals to 5.25. Okay, so that's the variance of y. We have the covariance of x and y, variance of x and variance of y. Now we are ready to get the final variance we want. We wanted variance of x plus y. variance equals to variance of x plus variance of y plus 2 covariance of x and y. Okay, and this equals to, we have variance of x 1.96, variance of y 5.25, and we got the covariance to be negative 1.3. But don't forget the 2 here, right? 2 here is important. 2 times negative 1.3, and that's equals to 4.61. That's the variance of x plus y. Next, for the standard deviation of x plus y, all you need to do is just take the square root of the variance of x plus y. In this case, equals to the square root of 4.61. Okay, and this is how you calculate for the variance of the addition of 2 random variables. Okay, this video concludes the concept of dispersion of 2 random variables when they are added together. Thank you for watching. I'll see you in the next video.